I hope everyone's doing well. I'm Mr. Ish. Thank you for joining me. We're looking here at inhomogeneous equations. It can also be referred to as non-homogeneous. These are second order. We're looking here at particular second order. You can see it right here. It's a second order. First order and then your original y. You can rewrite this as this: a y double prime plus b y single prime plus c y is equal to f of x. You are familiar with part of these, but the ones you are familiar with are homogeneous. If f of x was equal to 0, where this thing right here was equal to 0, you had homogeneous, and this was generally of the linear form, a linear homogeneous ordinary differential equation. If this f of x, however, was not equal to 0 but equal to something else, a constant, a linear function, a quadratic function, a trigonometric function, exponential, whatever it might be, then you're looking here at inhomogeneous or non-homogeneous. But of course, second order differential equations, non-homogeneous. What are we looking at here in this video? Of this form. But there's so many of those forms, so we have to start slow and then go from there. What are we looking at here in this video? Three particular forms where f of x is not equal to 0. They'll be from easy to slightly hard. F of x here can be equal to a constant. That's what will be one of those, and we can write that as a c. F of x here can be equal to a linear function. We'll write that as a cx plus d. F of x can be equal to a quadratic function, and you know we can do cx squared plus dx plus e. These are the three varieties we'll look at over here. One example of each. How do you solve this? It's rather complex because when you're solving inhomogeneous, you're bringing in the items and the procedures for homogeneous, and you're pairing it with something new. So you're going to be bringing in your techniques, from homogeneous differential equations, then you'll add into a new technique to get your general solution. Your general solution here will have two items. GS, general solution, will have a complementary function and a particular integral. This complementary function item here you will determine from the items and the procedures from solving homogeneous differential equations. This particular integral will be related to what you see over here, where you're focusing only on this part right here, using the new set of procedures to add that. Then you pair them together to get to your general solution for the second order inhomogeneous or non-homogeneous differential equation. So let's start. The absolute best way to start is from easy to slightly hard, but keeping the template the same, because then we will add onto it. This right here is my second order inhomogeneous or non-homogeneous differential equation, ordinary, but it's inhomogeneous because here the f of x is not equal to 0, it's equal to something. Here your something is equal to a constant. Focus over here. If your f of x is equal to a constant, then we're looking here of the variety f of x is equal to c. Remember that, because then we will get our particular integral from that. Now we are going to start and focus over here. Remember I said you're building in on your techniques from homogeneous and then you're adding on, where we're doing the homogeneous part first, and this is how we'll do it. I'm going to abbreviate it. Double prime minus 5 single prime plus 6y is equal to 0. Why have I equal to 0? Because I told you the part of the solution is coming from a homogeneous technique and the rest of the solution is coming from inhomogeneous technique, so we're starting with this. You remember this when you have a homogeneous differential equation of the linear form, especially where you're expecting real solutions. You're going to do y is equal to e to the power of rx. A first order derivative is equal to r e to the rx, and you have videos available from my channel for all of this. Second order derivative is equal to r squared e to the power of rx. You bring in these substitutions. The second order derivative is r squared e to the power of rx minus 5. Your first order is r e to the rx plus 6 e to the rx is equal to 0. What are we focusing on right now? Right here, your complementary function, that part. The general solution is made up of two items. We're focusing on that item using our homogeneous technique. Isolate e to the power of rx. X or rx, it doesn't matter. Order does not matter when you're multiplying. E to the power of rx, I have here r squared minus 5r plus 6 is equal to 0. You push this on the other side, you can just cancel out. Find your solutions. There are two real solutions. You have r minus 3 and r minus 2 is equal to 0, and r is equal to 2 comma 3. My CF, my complementary function, I'm erasing this because we don't need this for now. We've used it. My complementary function part of the general solution will be equal to, using this, you think about back to our homogeneous videos, it'll be y is equal to a e to the power of 2x or 3x plus b e to the power of 3x or 2x. You could either put 2 here or 3 here or put 3 here or 2 here. It doesn't matter. It's the same. This is your complementary function. Now this part is done. We have to focus now on the particular integral. For the particular integral, we now focus only on the function part, f of x. Here f of x is equal to 24. Now this is what I'm looking at. F of x is equal to c, and you know f of x is synonymous with y is equal to c. Then my first order derivative dy over dx is equal to 0. My second order derivative d square y over dx square is equal to 0. I'm going to take these items and I'm going to plug them right over here. I have a d square y over dx square, which is a 0, minus 5 times your first order derivative, which is 0, plus 6 times y, which is equal to c, is equal to 24. This cancels out, this cancels out. Well, it zeroes out. C is equal to 4. This is what I have determined here. C is equal to 4. Now, how do I marry it in? Well, here it is. General solution is equal to a complementary function plus your particular integral. This right here is my particular integral, and we have it. I'm going to write our solution to this second order inhomogeneous differential equation. My general solution is going to be this. It will be this. A e to the power of 2x plus b e to the power of 3x plus 4. Here's my complementary function part, here's my particular integral part, and you can write all of this is equal to y. And you're done. This right here is a inhomogeneous equation, second order differential, where your f of x is equal to a constant. And you see the procedure has been brought before you. We have two other forms to look at, where your f of x is equal to a linear function and where your f of x is equal to a quadratic function. Or question number 2, look right here, modification 24x plus 2. I've changed it into a linear. It's no longer a constant, but it's a linear function. You're going to focus on this part again, and you will do your complementary function. You know that. We had r squared e to the power of rx minus 5r e to the rx plus 6 e to the rx is equal to 0. That part is the same, and you solve this out. You'll have r squared minus 5r plus 6 is equal to 0. You have r minus 3 and you have r minus 2, and you're getting here y is equal to a e to the 2x plus b e to the 3x. That's what it is, because r is equal to 3 comma 2 or 2 comma 3, doesn't matter. You could change the order over there, but that right there is your complementary function. Now what we have to do is focus on the particular integral. The particular integral, you always look at the f of x part. What does that mean? You're looking at the right hand side. You're looking at the left hand side for your complementary function. You're looking at the right hand side for your particular integral. Our particular integral is looking of the form. We know we had something of this, cx plus d is equal to 24x plus 2. If y is equal to cx plus d, then the first order derivative dy over dx is equal to c. Then the second order derivative is equal to what? 0. You're going to take these items and you're going to plug them in, and you'll solve for the values of c and d using systems of linear equations. I have d squared y, if my second order is equal to 0, I put it here, 0 minus 5 times dy over dx is equal to c plus 6 times this cx, because I know y is equal to this, my f of x is equal to all of this right here. Therefore y is equal to all of that, and you substitute it right here. 6 times cx plus d is equal to 24x plus 2. Systems of linear equations. You don't need to see this. Let's work on this systems and find the value of c and d. I have here a minus 5c plus 6cx plus 6d is equal to 24x plus 2. Find all your constant terms, find all your linear terms. My linear terms are those with the x. My constant terms are without the x. I have my linear term 6cx is equal to 24x. The x's cancel out. C is equal to 24 divided by 6, which is 4. Now let's focus here on my constant terms. And what are they? I have a minus 5c plus 6d is equal to 2. But I know the value of c is equal to 4. Minus 5 times 4 is what? A minus 20. Minus 20 plus 6d is equal to 2. You push this on the other side and solve for d. You have a 22 divided by 6. d is equal to 22 divided by 6, which is what? 11 over 3. We have the value of c, we have the value of d. Now we'll present our general solution, which is our complementary function. You see it right over here, plus our particular integral, and we will post it for you. My general solution for this inhomogeneous or non-homogeneous second order differential equation, where my function is equal to a linear item, is equal to y equals complementary function. I have it right here, a e exponent 2x plus b e to the power of 3x plus my particular integral, which is this. How do I know how to write my particular integral? I know it's of this form, linear variety. It's cx plus d. This is how I do it, cx plus d. C is equal to 4, 4x plus d, 11 over 3, and this right here is our general solution. And we are done with this question, where the function is a linear item. Last question for this video, where we have everything the same except our function at the end. This right here is my function component. It's become a quadratic item. We started with a constant, then we went to linear, now we're gone to quadratic. Remember, you're finding your general solution to be equal to your complementary function plus your particular integral. This thing has not changed at all. I remember my complementary function was equal to a e to the power of 2x plus b e to the power of 3x. That's what it is, because you're doing this and equaling it to 0, and you're using your basic homogeneous solving procedures. This 2 and this 3 are interchangeable. You can do a e to the power of 3x, or you can do b e to the power of 2x. It doesn't matter, because when you're getting your solutions r is equal to 2 comma 3, it's no different than saying r is equal to 3 comma 2. You can pair this with a, you can pair this with a, you can pair this with b, and you can pair this with b, and it doesn't matter. The order particularly does not affect your general solution. So we're good. What we have to do is focus on now the particular integral part, which is the second part of your solution, and we can. When we have a quadratic thing, we're looking here at y is equal to cx squared plus dx plus e. This is what we have. Then you have to run this to our derivatives because we have a second order. Then I'm looking here at dy over dx is equal to 2cx plus d. Then I'm looking here at my second order derivative, which is going to be 2c. That's what I have. Now these items have to be substituted in here, and you equal them to x squared. This part gets messy now. Our second order derivative here is a 2c minus 5 times your first order is a 2cx plus d plus 6 times y, which is all of this. Cx squared plus dx plus e is all equal to x squared, but write this out as x squared plus 0x plus 0. That we have all the different varieties of items, your quadratic, your linear, and your constant. Now we have to solve all of this out. You will obviously open up everything. When you open it up, you have a 2c minus 10cx minus 5d plus 6cx squared plus 6dx plus 6e is equal to x squared plus 0x plus 0. Pair up your quadratic terms. I have a 6cx squared. Here's my quadratic terms. Because our space is limited and I don't want to get messy, we'll do one item at a time. I have 6cx squared is equal to x squared. 6cx squared is equal to x squared. X squared can be pushed on the other side. I have a 6c is equal to 1. C is equal to 1 over 6. So we'll put that right here. C is equal to 1 over 6. Now let's just push this aside and let's work on something else. We're looking here at our linear terms. Our linear terms are the ones with the x's right here. I have 1 over here, and then I have 1 over here. What are these? I have a minus 10cx plus 6dx is equal to 0x. Now focus over here. Minus 10cx plus dx is equal to x. In all instances, if you want, you can cancel out the x's because you can divide everything by an x and it'll go away. You'll bring in the value of c right here. I have a minus 10 times c, which is 1 over 6. I have a minus 10 over 6 plus 6d is equal to 0. You're solving here for d, and it wouldn't be hard. D is equal to, you're pushing it on the other side, 10 over 6 over 6, and you know that'll be a 10 over 36, and you know that'll be a 5 over 18. So we have that done as well. I'll put that right there. D is equal to 5 over 18. It's nothing other than systems of linear or quadratic equations, and you're one by one running it through. Sometimes the examples are hard, then you actually have to do matrix algebra or whatever type of algebra to determine your solutions. Now the only thing which remains are the constants. I have this 2c, I have this minus 5d, I have this 6e, and I have this 0. And let's bring it in. I have a 2c minus 5d plus 6e is equal to 0. I have values of c and d. I would plug them in. C is 1 over 6, d is 5 over 18. 2 times 1 over 6 is a 2 over 6, which is a 1 over 3, minus 5 times 5 over 18 is a 25 over 18. Plus 6e is equal to 0. If you solve this out properly, I won't spend time, but the fraction algebra and all of that, you get a value for e, and your value for e, 1 over 3 minus 25 over 18 plus 6e is equal to 0. E will be equal to 19 divided by 108. Let's put that over here. 19 over 108. We have our value of c, we have our value of d, we have our value of e. These are your particular integral parts right there, your pi. Let's bring everything together for our general solution. We'll make the space and we'll complete this question. So I've cleaned everything out over here for the presentation of that final answer, the general solution for this inhomogeneous differential equation where your function is equal to x squared. You will start over here with y is equal to your complementary function. You know that to be a e to the power of 2x plus b e to the power of 3x plus. How are we going to write the particular integral? Well, we're looking here at a form cx squared plus dx plus e. We have these items c, d, and e. Just plug away. Cx squared, which is 1 over x squared, you can write that as x squared over 6. C is 1 over 6 times x squared is x squared over 6. Plus d is 5 over 18. I can say 5x over 18. And finally, my e was 19 over 108. This right here is my solution. All of this boxed item is my solution. It's made up here of a complementary function. It's made of your particular integral. The general solution for an inhomogeneous has these two components, and you see them before. This solution should be good. Let's just end this video with a very quick recap of what you need to be aware of. In this video, we looked here at the second order inhomogeneous differential equation of this form. Second order, as you can see right here, where the f of x is not equal to 0. This item right here. If f of x is equal to a constant, let's say k, then you will use as your template y is equal to c. If this f function over here is a linear item, we can just abbreviate as kx. Then you will use as your template y is equal to cx plus d. And obviously you're doing the first and the second order derivatives, you're plugging away, then you're going from there to determine these are your items for your particular integral, the template or the technique you're using. If you're looking here at a quadratic item here, right here, it's quadratic, then you will use y is equal to cx squared plus dx plus e. This right here is the basis of everything you're doing for your particular integral. Your complementary function is coming from your homogeneous techniques. This right here is giving you the second item of your general solution. And that right there is the end of this video. Thank you.